In this section, we're going to look at what happens when we switch x and y in some familiar equations. So far, we've worked with functions that look like this, y equals x squared. We had functions that were a little bit more elaborate, like y equals ax squared plus bx plus c. And we made parabolas with those functions. But we're wondering, what happens if in this equation we switch x and y? What would you guess that the equation x equals y squared looks like? Well, if your guess was that the equation would look like this, you were indeed right. When we switch x and y, it's like we're flip-flopping our x and y axes, and we rotate our graph by 90 degrees. How would you graph this on a graphing calculator? Well, you know that your graphing calculator typically only accepts inputs that have y equals some stuff. And so you might have to solve for y in this equation. You might take the square root of both sides of this. And so you would get y equals the square root of x. And this is something you can fairly easily graph on your graphing calculator. Question is this a function? Y equals the square root of x. Right now, this isn't a function because there are two possible outputs, that is y values, that go with one input, one x value. Here's an example. Suppose that x is 49. Y could be positive 7 or y could be negative 7. So right now, this relation, y equals the square root of x, is not a function. For the remainder of this chapter, we're going to talk about the square root function. And what that means is that we agree that we're only going to look at the positive square roots of x. So we're only going to use the positive 7 in this case. In part, this is because our calculator can't handle relations that are not functions. Because our calculator doesn't know when we put in a 49 for x, whether it should choose the positive 7 or the negative 7. So we make an agreement that we'll always look at the positive square roots of x. We call these radical functions. When x is underneath the radical sign, we've so far called it the square root sign, but it could be, we could put a little 3 in there and make it a cube root, or a little 4 in there and make it a fourth root, etc. Anytime x is underneath that radical sign, we have a radical function. So one example of a radical function is y equals the square root of x. A second example is y equals the square root of x, and then add 4 to that number. A third example is y equals the square root of the quantity x plus 4. Notice that these last two are different in whether that 4 is underneath the radical sign or not, and that's going to make a difference in the graph. So one of the things we need to do is to identify the domain and range of these functions. So one way we can do this is by graphing the function and looking at its possible x and y coordinates. So if we graph the function y equals the square root of x plus 4, if you do this on your calculator, what you'll see is what's shown in red at the right here. This looks like it's only half of the function. Remember, we said we were only going to look at the positive square roots of x in order to make this actually be a function, and that's why we only have half of that parabola. So we graphed it. Now we can look at this graph and ask ourselves, for all the points covered up in red there, think about what their x-coordinates could be. It looks like their x-coordinates could be anything 0 or greater. So our domain, what we could plug in for x, is anything 0 or greater. And that makes sense in the context of our function. Think about what would happen if you tried to plug in a negative number for x. You'd be trying to take the square root of a negative number, and that wouldn't give you a real number as an answer. So you're only allowed to plug in numbers that are 0 or greater for x. So the domain is x is greater than 0 or equal to 0. Then we can look at what y values. Right? So if we focus on that red line, and think about the y-coordinates of all the points on that red line. They start at 4, and they get bigger and bigger and bigger. The smallest y-coordinate for any point on that red line is 4. So our range, y, has to be 4 or greater. And again, that makes sense in the context of the function. Look at the equation above. Is there any number you could plug in for x that's going to make the square root of x plus 4 be less than 4? If there were such a number, it would mean that you took the square root of x and what you got was negative. And we said that for square root functions, we're only going to look at the positive square roots. So that first term in our function, the square root of x, that can never be negative. So we can never take away something from 4. We can only add things to 4, and the smallest thing we can add to 4 is 0. So the smallest y value we can get out of this function is 0 plus 4, or 4. So the range is y is greater than or equal to 4. And you can tell that by looking at the graph as well. Okay, so this is the very most general form of a radical function. Y equals some number, a, times the square root of some quantity, x minus h, plus some other number. And I want to know, what effect do these three constants, a, h, and k, have on the graph? Well, let's look at them one at a time. A makes the graph stretch up or stretch down, just like the a in y equals ax squared plus bx plus c did. So if a equals 1, our graph might look like this. If a equals 0.5, we're going to flatten our graph. It's going to have a vertical shrink because we're squishing it down. If a is greater than 1, we're going to have a vertical stretch. We're going to stretch our graph up. And if a is negative, it's okay for that coefficient out front to be negative. That's going to flip the whole graph over. So if a is a negative number, it just takes the positive graph and flips it upside down. It's a reflection across the x-axis. So a changes the shape and reflection of that graph. H is going to shift the graph left and right. So if we start off with our original graph there, that's h is 0. If h is negative 3, the graph is going to shift left. It's going to move in the negative direction by 3 steps. If h is positive, the graph is going to shift to the right 3 steps. So h moves the graph along the x-axis. It might help to notice that h is sort of snuggled up against the x underneath that radical sign. So h changes the x-coordinate, which moves the graph left and right. So you can probably guess then what k does. K shifts the graph up and down. So our original graph would have a k of 0. If we have a k that's negative, our graph is going to shift down. K of negative 4 shifts our graph down by 4 units. K of positive 4 shifts our graph up by 4 units. So k makes the graph move up and down. Notice that when you're working with functions like this, you have to have it written as the square root of x minus h underneath that radical sign. So if you have something that starts out as x plus h under there, you might have to do a little bit of tricky rewriting, writing that as x minus negative something. Because you always want the stuff under the radical form to be written as x minus some stuff, and that stuff might be negative.